Hi. Today the main topic is what is the fetch in CPU. Last video I talked about what is a bus. So the bus is just the group of wires that connects between the CPU and memory. I know there's those kind of stuff, and there are three types of the bus. Of course, the bus is just a group of wires, but there's a purpose of these wires, and which is for the address sending order, which is for the sending data, or which is for the sending control signals. And we just can divide into three types of the bus, which is the address bus and data bus, or the control bus. And also I talk about the instructions, and the instructions it's just the command that we have to define to the CPU that CPU has to do something. So that is called the instruction. And if you look at the instructions, and it usually defined as the assembly language, and it's called assembler ISA instruction set or whatever. And it's basically this instruction is basically depends on the CPU architecture. And I know, but the thing is that most commonly there are some move instructions and also there's like push or pop or add or subtract, and there's a lot of things. But let me skip let me just skip that thing. But we're trying to talk about the fetch. In the CPU, the processor part, there are three actions, which is fetch and decode and execute. It's really simple, right? But let me try to explain this more. Inside BIU, bus interface unit, we're trying to do in the fetch, and after fetch, we're trying to do the decode and execute in the execution unit. And so, what's the fetch? The fetch is basically just getting the next instruction that you define. What do you mean by that? If you look at, if you try to make some kind of some kind of program using the assembly language, you're able to see some kind of move instruction, those kind of thing, and you have to define the per line by line. And the thing is that the processor, the CPU, only execute this part per instruction, and so we have to store this kind of instruction set into our memory, and after that we have to fetch after we done this instruction, right? So that is why we use the fetch. So fetch is basically I wanna do something, and but I store the command in my memory. So let me just try to get it. I'm just gonna really simplify for you. Example, you are the chef. Not you're just the owner of the restaurant, a pretty nice restaurant. Let's say you're just Gordon Ramsay, and there's a chef. You're just owner. You're Gordon Ramsay, and you have to hire the chef, right? And there's a chef, and chef has to tell the waiter to get the food that I made and send it to the customer. And also it has to chef has to tell the waiter what to do, or to get some food inside the refrigerator or those kind of thing. And this refrigerator, it's just a storage, and there are bunch of things of there's a bunch of food up there, and also there's a bunch of things that the food has to be ordered. Example, in the first refrigerator, there should be dessert, because in the restaurant you have to serve some kind of fancy endless food, right? The first thing is the dessert, then second thing is some kind of meat, or third is just the noodle or those kind of thing. So you have to give this food by per line by line, and the customer has, of course, customer we're gonna just eat this. So this just what I just did was this kind of example, very simplified example of how it works. The CPU is a chef, and the refrigerator is the memory, and this first part, the first storage and second storage and third, and the food here is the instructions, and the waiter is the bus, address bus, data bus, and control bus, and the customer is the one who I don't know. Is I don't know who the customer was. I'm just trying to say. You know, so after you receive the, let me just try to explain furthermore. So, example, you want to get the address that located in, you want to get the instructions by locating their general address. So you send the zero to the address bus. So you're just gonna get it, and after that, you were able to get some kind of instruction here, and you fetch it. And also the control has to be some kind of read on write. So control is a control bus. It's just a road or highway that makes you to send the control signal, which determines what to do with this memory. You can just write memory, or you can just read the memory, and that based on the control signals. So if control signals read, you're able to read it. So after that, you're able to get it, and you put the new instruction, this fancy, delicious instruction, in the queue of it. The queue is just the data structure that it's just the FIFO, first in first out, and after that you enqueue it, and and the EU, excuse me, will dequeue the first part, and of course the first part is gonna be first instruction here, and after that you were just doing the decode thing, and you're just gonna decode, and you were just based on this decode value, and you execute it. So that is really hard work. The fast decode execute, fast decode execute. And why this EU doing the decode and execute, the this BIU will eventually doing this fetch, but same time. What I mean the same time is we're just gonna do the fetch, but while it's doing the fetch, this EU gonna be doing the decode and execute. Yes. So that is really simplified of the fetch. I know there's more. Um, I know there's more, and yes, and of course, the getting orders value is co-segment. The formula of getting the orders value is just the register, segment register, times 16 plus pointer register, but in the real mode. I think this is it. But next video, I'm just gonna try to talk about the decode, because we talk about fetch, right? But what I'm really worried is because I'm implementing the fetch in my code, but the decode thing is really hard. The decode is really confusing. So I don't know if that's really practical or not. I know to understand decode is kind of necessary, but does it really necessary? Does it really practical to understand why is the decode thing? So I don't know. So I'm just gonna study it first. But if I think this is really practical, I'm gonna explain it. But if I think this is not practical, I'm just gonna skip it. So this is it. yeah, see you next time. Bye bye.